In the last session, we have discussed the real gas equation, that is van der Waals gas equation. Today we are going to discuss the compressibility factor, that is Z. It is also used to measure the deviation from the ideal gas behavior. It is the ratio of the product PV upon nRT. For ideal gases, compressibility factor is 1. For ideal gas, Z should be equal to 1 at all temperature and pressure because PV equal to nRT. So its value should be equal to 1. Now we are discussing here the condition at which the compressibility factor can be 1 for the real gas. What are these conditions? Firstly, we are discussing the pressure. If the pressure is very low, then compressibility factor can be 1. How this is possible? As the pressure is very low, at this pressure, as intermolecular force of attraction, which is represented by the van der Waals gas constant A, is neglected, and the volume occupied by the particle, which is represented by the van der Waals gas constant B, it is also neglected. So that is why the gas will behave as an ideal gas. Now there is the second condition. Second condition is when temperature is very high. When temperature is very high, then also volume is very large, because we are assuming that volume is directly proportional to the temperature and we are keeping the pressure constant. If temperature is very high, then volume is also very large. Again, if volume is very large, then volume occupied by the gas particle is negligible, and the intermolecular force of attraction between the particle is also negligible. As the volume is very large, the particle would be distance apart, so the intermolecular force of attraction between the particle would be negligible. So these are the two conditions at which the real gas can behave as an ideal gas. That is, when pressure is very low, and second, when temperature is very high. Now we are going to discuss the condition at which the Z is less than 1 for the real gas. The condition is if we take the pressure of the gas to be low, then at this condition the compressibility factor for the gas would be less than 1. How it is possible? Because pressure is inversely proportional to the volume while keeping the temperature constant. Then if pressure is low, then volume is large. We have discussed already that when volume is large or it is very large, in both the condition, the volume occupied by the gas particle is negligible. Therefore, in real gas equation, this term V minus NB would be approximately equal to the V. But as the pressure is low, then van der Waals gas constant A, which is used to measure the intermolecular force of attraction, it is not negligible. Thus, at low pressure, the van der Waals gas equation would be P plus A n square by V square into V equal to nRT. Here V minus NB is taken as V. So if we multiply V here, then we will get PV plus A n square by V equal to nRT. By dividing with the nRT on both sides, it would be PV by nRT, which is Z, compressibility factor, which is equal to, if we take this term to that side, 1 minus AN by VRT. So the compressibility factor Z value would be less than 1 when the pressure is low. So for real gases, compressibility factor less than 1 is possible when pressure is low, but when pressure is very low, the compressibility factor would be equal to 1. Now we are going to discuss the second condition at which the Z is greater than 1 for the real gases. If the pressure is very high, then the Z is greater than 1 for the real gas. If the volume of container is small, so the volume occupied by the gas particle is not negligible. Second point, when the volume is small, then particles would be very close to each other, and if they are close to each other, then intermolecular force of attraction does not dominate. It is the force of repulsion which dominates. So van der Waals gas equation at high pressure is P into V minus NB equal to nRT. Now, if we open the bracket, we can say that it is PV minus PNB equal to nRT. By dividing by nRT on both sides, we will have this equation PV by nRT equal to 1 plus PV by RT, where PV by nRT is compressibility factor, which is equal to 1 plus PV by RT. So compressibility factor is greater than 1. So we can relate this one with the previous one, that condition at which Z is less than 1 was pressure is low, and the condition at which Z is greater than 1, it is pressure is very high.